Hey guys, Andrew Hall. I've been an NDT tech for 15, 17 years. It's been a long summer job, and I'm here to talk to you about magnetic particle inspection today. Oh, I've already started on the board. Let's erase it a little. Here we go. So the absolute basics, first of all, magnetic particle exam works on surface, near surface defects. Let's just draw a picture here. So we got an indication, we got a little crack. Let's pretend the crack's under the field. We're going to apply a north field and a south field, kind of like when you drop, I'm going to redraw it right here, kind of like when you drop a magnet in the shop and it comes up with little metal filing hair all around it. The file is attached to the edge of the magnet. If you have a little crack that's breaking surface or darn near to, the flux fields are going to come in, they're going to jump over a little, they're going to come in, we got to jump over, we're going to come in, we're going to go under. This part here is going to attract hair. The same goofy metal filings. This is our metal filing. We keep it in a little puffer. It comes out, there you go. It comes out red, it comes out light, very fine particle. You'd throw that, the red hair would land on top of your indication. Now, if you got a subsurface, the flux field, I don't need to tell you guys, the flux fields will kind of stay close to the top. There's no reason for magnetism to just take a deep dive and see what it's like 2 inches under the equipment. In general, AC, surface defect only. If you're going from AC to DC, then you get about, don't quote me on this, about 5 millimeters of penetration. You can get a crack that's not quite under surface. Boy, not a great pen. It'll come up, bounce up. You'll get a light indication up here. That's kind of the basics. You'll make a new north and south field. Where those two touch, you're going to collect this metal filing. It's going to show you where the cracks are. When you do it, a certified NDT tech has all of these tools at his or her disposal. And we'll kind of get into it. It's not too complicated. The most important thing you need to know, you guys already know, you have permanent magnets that exist. It's not too common. There's nunchucks for permanent portable magnets, but usually you use an electromagnet, a welding machine, a mag bench, an electric yoke, because you can apply an electric field to something. If you have an electric field, you guys know, right-hand rule, you're going to make a magnetic field. And if you have a magnetic field going end to end, you'll find indications that are going against the field, generally the direction of electricity. So electric field, magnetic field, a crack you can find. A crack in this location, if there was a crack along the surface of this, the flux field would just go underneath it. It would go around. If there was a north and a south, the field would just, lightly go around it. You'd never even notice. Whatever. Okay, so our equipment, we'll start with this because it's big, it's impressive, and we hardly use it. It's an aircraft thing, it's a part inspection thing. It's not, there's a transformer in here. This is a profoundly immobile piece of equipment. So if you're doing hundreds of thousands of, these are brass, but we use them for center shots, of rods, of pistons, of crankshafts, of bolts, yeah, you'd have a piece of equipment like this. You just spend all day turning the equipment on and off and on and off and on and off, checking what you're going to see. You can do a couple different things here. You can do contact shot, you can't see, or a coil shot. If it's contact, power comes out of here into here. And then you have an electric field, a magnetic field, and a direction of indication along the thing. Or you can switch it to the other one, and then you're looking at, oh, come on! Our coil shot. Now the power is going in one side, out the other, but before it goes home, it does 1, 2, 3, 4, 5 loops in here, and then out the other side. Electric field, magnetic field, direction of indication. That's the number one rule you got to keep an eye on. It doesn't, if I'm magging this way, I'm not finding an indication going this way. I'm finding an indication going this way. We know where a shear pin shears, so we know what we're looking for. That's this guy. Then we have kind of the same piece of equipment. This started as a welding machine. This is an awfully nice one. But you just have your welder. You can turn up the voltage and amperage. which would affect the magnetic power output of your unit. You just straight plug welding cable into your outlets, DC, AC, makes, here we go, this is the same thing. 1, 2, 3, 4, 5 loops in one small piece of equipment you plug in. These leads can be, well, not 100 foot, there's a certain amount of loss. But you could have these, the diameter could be 1 meter. These leads could be 10 feet long to keep you away from it or be slightly mobile. Your power supply is right here. This one's nice because it has a DMAG option. We're gonna get into it, but that comes up. You put it in a generator, man, you can't put a magnetic piece in there because you're gonna start sucking metal filings into spinning copper. You're gonna mess something up. You gotta demag those pins before you put them back in. So we do that, we can do this, or we could plug in, I don't have the cable for it right now, something like this for a prod shot. Prod shots are slightly different. Prod shots versus, they look similar, a yoke. The yoke has a bunch of wraps in here. The power comes in, it does a bunch of loops. We got a north and a south. You put it down, you find indications in between. This one, power in, well, positive, negative. So your power, you will close the circuit with the piece of equipment you're magging. When you do that, you put an electric field, a magnetic field, and an indication field versus this one. So you got electric, magnetic, indication. This one, you have magnetic, indication. They look the same, and they work in reverse. These aren't too common anymore. As a part of this being a part of closing the circuit, I got sparks, you'll put arc shots onto the piece of equipment. Well, rule number 1 of non-destructive testing is you're not supposed to be putting arc shots on things. You're gonna put heat effects in things. You're gonna damage something. Rule number 1, cause no harm. It's not just doctors, us NDT guys too. So we've done this, straight shots through, coil shots, prod shots, and then this guy here is our workhorse, the yoke. This is remarkably portable. If you have power, it could be a small generator, it could be an inverter set, you can bring that with you. Conversely, you can get those nunchucks I was talking about, which are, how'd I lose my pen? Lord Thunder help me. Here we go. The nunchucks are just 2 permanent magnets, and they're connected, you're not gonna believe this, by a string. And you just put one here, one there, you put a north field and a south field. I can't believe how bad this pen is. Now you got a north and a south, and the field goes in between them, and you will find indications between your field. These weigh, 15 pounds. They're heavy, and they are strong magnets. And you have to calibrate them semi-regularly. Actually, you have to calibrate all this stuff. This bench, we do an output curve. We do it quarterly, every half year or so. This one we should do again, I guess. Where you just measure its set output against a shunt, just to make sure you're not losing it. You can't be pretending you're putting 2,000 amps in, and in actuality, you're putting in 1,000 amp. There is, here, let's flip a page here. There is a known sort of amperage you should be hitting for a diameter of pipe. There's a great deal of math that goes into it now. You guys probably know that. That, you can tell, is an old as heck book, but a quick way of getting the answers. Well, I didn't talk about center shots. So that's what these guys are for. So the other thing you can do, if you had a bunch of rings to inspect, that's a little short, let's just tighten it up a little, is you put something, close enough. You'd put it in there, you'd run your power not through the piece, but through this rod. Now you have current, magnetic field, inspection direction. So if you had a ring, you could find a crack that's going through a ring. I think that's it for method. So now we got to talk about the particles we'll use. So these baths generally run on a fluorescent oil-based, what's it called? It's a spray. It'll have in solution metal filing that fluoresces under black light. These guys, you can use the same fluorescent equipment. Just bear with me, I'm gonna grab a can. Of course, we keep it in a fire cabinet, because why not? There we go, we got one of these. We don't have any water base in here. Oh, we do too. You better believe I couldn't believe it. So we got oil and water base. You can make it yourself. You'll need a water softener. There's something to be said about spreading. So basically, if you just mix metal filing in with water and you spritzed it like you had just a water bottle, you'd end up with little balls of water. You need something to soften it and make a plane. Because the number one thing about using mag particle is you need particle fluidity. You need to make sure that if the crack is here, but those bubbles aren't touching it, well, shoot, you got to make sure that the bubbles touch each other so the particles suspended can go straight to that crack. If they're not touching, they can't touch. If this guy's spraying out heavy-ass clumps, I'll never see a crack under there. You'll mag it, it'll just be a big red mess. You got to have a light hand, that fine powder will to one spot. This pile of crud will look like a pile of crud, and cleaning it up will leave you stained red. Anything you touch stained red. So you have to kind of be a little considerate of what you're doing with this powder. You can also get, this is fluorescent oil base, you can also get just black particle oil levied. So you'd spray it on. This is bringing us to our next thing. You're gonna need comparator. So this one I've already magged. Can you see the crack? I mean, maybe, hardly, because it's rusty on the inside. That's kind of the thing. Things in service tend to get rusty. The paint comes off, it exposes itself to water. Oh, we'll shoot it again right now, because why not? This is the only one I have turned on. So, north, south, could be backwards, hardly matters. Oh, makes a good noise. You can hear that magnetic power. Yeah, good enough. We'll get to this in 1 sec. I'm just gonna grab, I need 2 hands for this. Okay, fresh puff on there. You can't really see. But if we spray a little contrasting agent, that could be a paint. Oh no, that's not gonna get me anywhere. Unbelievable, I'm really sorry guys, it's rookie hour here. I couldn't feel worse about this. I feel like a buffoon. There we go. This is just a alcohol levied chalk. When you spray it on something, here. Just makes a white background. And the chalk and the alcohol evaporates away. Well, already you can see that crack better. I haven't even sprayed the fresh stuff on yet. Let's do it quick. Again, hey, bear with me, guys. I'll try to make it so you can see me do it. Oh, that's not bad. Now, I can't adjust focus, but with a contrasting agent, you tell me that's not cracked. I'll tell you it is. Oh boy, angle. There. Oh, you get it every now and then. There we go. You got her, guys? Little crack in there. That, you can see that you got a contrast. Now you got the question of penetrating power. DC has slightly more, AC is what we're using. If you when you mag something that's covered in paint, let's just say, the cracks under here, I mean, you're hoping that the magnetism penetrates the paint, goes through the part, makes a field that will make an indication over the paint. If you have quite a thick paint, I mean, that's ridiculous, but if you had quite a thick paint, you're really separating yourself from the thing you're testing. So if you're concerned, sometimes you'll look at something and you'll see, you know, a crack in the paint next to a fillet weld. There you go, that's kind of a 2D version of a fillet weld. That's the worst fillet weld. Here, I'll do this so you know where the fillet weld is. So if you had a little crack in paint that ran through here, paint's already broken. We might scrape that off and then mag it through there. That would be, if you have to see a heat-affected zone crack in this area, that's how you do it. Let me think about this. Mag bath, water with a softener, oil's pretty good. You can't always use water or oil. Sometimes you have to keep the thing clean. Sometimes you have to use water because you can't put oil on it and become conductive. You can't use water, you might accelerate rust. Sometimes you can't use light powder because it'll get sucked into a generator and cause real problems. Post-cleaning, demagnetizing can become a real part of the project. Oh no, my nice shirt. I wore this just for you guys. You didn't even get to see. And I got this red crap on it. Let me think about this. What else do I have to tell you? I think that's shoot near it. I'll tell you what, if you guys have any questions, I think I am currently available at the end of your class. I'll talk to you later.